Right guys, another quick video. This is a flat earth video. I've got here a test that somebody that's located near a salt flat can do. It doesn't require a lot of expensive gear, but it does require some gear. What we've got here is we've got three 6 foot or so platforms. Doesn't really matter what height you make them, just so long as they're off the ground. The idea of it is to try and stop any reflection and refraction off of the salt. So the higher you can get it up off the ground, the better. This sort of experiment can't really be done in the day because there's too much heat haze and that. I'm obviously from Australia, and I mean, mirages are just, Australia is a mirage. The place is that hot most of the time that the whole place just shimmers, and what you can't see is what you can see. It's just a visual distortion a lot of the time in a lot of the country. So this experiment has to be done at night when it's cooler, so there's a lot less distortion. The salt flats sort of remain a little bit cooler because they reflect a lot of the heat off. So now the salt lake or the salt flat, when it's inundated with water, you want to know that it's a level lake. It's not got a deeper patch in the middle or anything like that. It's got to be something where you can see the water birds walking around in any area of the lake, like the flamingos or whatever you get in America or wherever. If you do this at Bonneville or somewhere like that, you should be able to, anybody that's local would tell you whether the actual level of the water when it's in there varies at all, or whether it's all level. Most salt lakes are renowned for being very, very level. We've got Lake Gardner, Lake Eyre and places like that, which most of the time are just salt flats. Very level, very good place to do a test. So the first thing was light reflection. The second thing was I suggest that the end tower is lined up against a mountain or something like that, so you can actually just look down, through the starlit sky and just see roughly in the direction that this should be, because it's going to be a little bit hard to find, and I'll explain to you why later. What I suggest is you take two instruments out. You take two torches, that one and that one, and a telescope or binoculars would do. You probably want like a really, really good torch, 5,000 lumens or something like that. You want something that's really, really powerful, just to make sure that you sort of, you can see it. There's no sort of question that you can actually see the beam or not. The other thing what I would suggest is a laser. Now the reason I'm suggesting a laser as well is because the laser has a different type of light emittance. It's actually a different, it's in the, I'm not a light specialist, but I imagine it's in a different colour range, and so any distortions that you might have because of atmospheric conditions or maybe magnetism or whatever could be quite different from a laser to a white light torch like a LED torch. They're the sort of areas I'm not really sure on, don't really know, so it's probably up to whoever does the experiment to determine what they want to actually learn of the experiment. So that's about all the basics. The test goes something like this. You place your first tower, 6 foot tower, at a distance of 5 miles from the next tower. Now you make sure that these are in a direct line. You can use your car GPS to probably draw a very straight line. Maybe if you're having some doubts about your ability to do that, maybe draw, drag something up the salt flat that's going to leave a little bit of a mark on the salt flat for the distance. So at night you can just follow that mark along, and then place these towers along the line. How you would do that was you would find a focal point down. You start at one end, find a focal point somewhere down the other end, and set your trip meter on your car and drive for maybe maybe 5 miles, or whatever distance you work out you want to do this over. I'd suggest you do it over about 5 miles. Place your first tower with a torch fixed so that the torch is shining perfectly level. Then you then drive up to your next position, which is 5 miles up. Place your second tower with your second torch on it, pointing in the same direction. So both torches are pointing towards your focal point, which is your telescope. Then 200 yards up from your telescope, from your last position, you would place your telescope. Now this is really, it doesn't really matter what this distance is. It's just far enough away that the difference, the minor difference in height from this area to this area isn't going to really affect what you see down the other end. So obviously the further you can get these apart, the better, but you still want them close enough that that you're not distorting, assuming that the Earth has curvature. If you put this too far that way, then this here will be pointing, it will be because of the curvature of the Earth, your telescope will be pointing up, and this will be already sort of on the downward slope. So that's not what you're after. All you really want to do is line up these 3 points of eyesight. So you see what I'm doing there. All you've got to do is set it up, make sure everything's exactly the same height, place them out on the flat, go up, look back through your telescope and try to line these 2 beams up. So if you line these beams up and they are directly in line, then we have a flat Earth. I would find very little to argue with I would seriously have to look at it if somebody came back and said, no, it's actually dead flat. Your experiment confirmed that the Earth is flat. I'd really have to go back and think about what I actually understand, because but what you will find is that at 5 miles, if this is 5 miles apart from this one won't be there. And you'll make all kinds of excuses. Oh, well, we couldn't see it because of the, the light wasn't bright enough or whatever. But ultimately, all it is that this is actually going to be 16 feet below this level shot straight across, this level shot straight across here. So go out and have a go, fellas. Be really keen to hear back from your experiments and what you discovered. I suspect what you're going to find is this one is actually disappeared, and as you travel back along your line, you can stop frequently, just get out with your telescope, and you will find that maybe at, 4 miles or whatever from a standing position, this will come back into view and you'll be able to see it. But I'm not sure I haven't actually worked out what the distance is, but it's not, it's only going to be 4 miles or something away, and it'll come back into view. But either way, that's my next experiment for you guys. all the best. I've been leaving a few comments around the place you've probably seen. Yeah, I hope I'm not offending too many people. That's certainly not my real intention. I do get a bit sarcastic at times, but alrighty. Now, the other thing that I've been thinking about is the reasons why flat earthers and globe earthers are at such an impasse where they simply cannot see each other's logic. The flat earther can't rationally say, well, it's because the ball earthers are just idiot shills and plain wrong, because there's just so many more people out there that are actually ball earthers than flat earthers, and they can't be all totally stupid. That it's simply not a valid argument to say, well, the ball earthers are either liars, shills, or just plain stupid. What I suspect it lies in is the education program that we've had. Now, from Australia, the teachers always had the globe model in a position where Australia was always on the bottom. Us poor buggers down here have never had the privilege of being anywhere near to the top of the globe, where North Americans have sort of been somewhere close to it. Now, what I suspect is that the Australians quickly grasped the concept that that Australia is actually always on top of the globe, as is every other point on the globe at all times, and that is dictated by the law of gravity. Gravity essentially overcomes the sphere and the perspective of the sphere. So what it does is it makes sure that every location on the earth is simultaneously exactly on the top of the globe. Now, Australians were sort of forced into understanding this concept. Otherwise, we would have all fallen off the bottom. So we sort of had no option. We had to grasp the concept and we had to understand it. Otherwise, we wouldn't be here. So we would have fallen off into space. And we'd be sort of hanging inside the dome there somewhere. So what I think it is, it's just a simple concept that we picked up, that people that lived in the Northern Hemisphere didn't actually have to face. And that's probably why the Australians are not terribly impressed with the concept of a flat earth, is because we've actually had to learn that it's a ball. So hopefully that's all good. Hopefully you can see me okay. I've got the camera reversed so I can't see what's going on. So all the best, guys. Shoot me some comments if you like. All the best.